Hello everyone, welcome to the course Climate Change Extreme Events. Today is a summary class and assignment of week 2. So far we had discussed about types and characteristics of extreme events in past 3 classes of this week. Starting with the heat waves, we have talked about how the heat waves can be classified based on the temperature thresholds. Then we have also talked about different types of heat waves occurrences across, let's say, Indian region and different parts of the world. We have also discussed about why different types of heat waves or intensity of heat waves has been increased in the this current decades as well. What is their correlation with the global warming conditions like that. Then we have also talked about various different examples. For example, European heat waves, the global example. Higher latitude countries are experiencing, let's say, higher amount of heat waves since 2003. This is a 2003 event which also tells about extreme severity of these heat wave events in the Europe. Then we have also discussed about in the future conditions, let's say 207 and 2100, we also observed there is a significant rise in the extreme occurrences of extreme magnitude heat wave events across different parts of the world or higher latitude regions, which needs to be to look at very carefully. Then we have talked about what is the exact mechanism behind if we have some sort of heat waves or events are occurring at a certain place, what is basically the reason behind it, what is the phenomena which is responsible for enhancing the heat wave impact on those particular regions like that. So, we discussed about heat waves are generally originated because of these high pressure system which is called blocking patterns, and which basically also sometimes refer to anti-cyclone areas where we have a large scale weather system characterized by descending air, and therefore, this air surpass the formation of cloud precipitation leading to more clear skies, and therefore, we have very heat events occurring during the day like that. So, these types of systems are we have discussed that these types of systems are often very slow moving and stationary, and therefore, it is called as some blocking patterns because the nature is there, the movement is very slow, the stationary and very slow, therefore, it is a sort of blocking system and because of the different types of winds and there. So, most of the time these systems are generated in, let's say, Europe, where we have already seen this 2003 and very recently 2022 heat wave events. Then we have also talked about North American heat waves event which has also intensified because of these blocking patterns. And then there is like Asian region where we have also pre-monsoon heat waves are often exaggerated by these stationary high pressure systems. So, generally in this system we have prolonged heat, stagnant conditions, and that basically reduces the overall wind activity, and therefore, we have a kind of sort of blocked system where the heat are trapped, and that is keep on warming the height of the atmospheric column, and therefore, that system some sort of enhanced by the positive feedback processes and all that. So, here we have also discussed about a kind of a domed shape formation of a particular place where because of the rise of heat heated air into the more sky, or it is enhancing in more elevation areas, therefore, it increases the sizes of this dome, and then we have more heating capacity stored in that particular areas like that. So, this is what exactly happening during the heat waves, and that is these processes which are primarily importance or propagating the effect of heat waves further in those areas like that. After this, in the lecture 1 we have also discussed about what is exactly cold spells or cold waves. We have talked the example of Siberian extreme cold which occurred in very recently 2023, and there is a North American cold wave which is occurred in 2019 like that. In this particular cold event, we have observed that the higher latitude regions which are very close to the polar regions were extremely vulnerable to cold events because of dropping of temperature to significant threshold, and therefore it is a very cold or extreme cold conditions was formed in those areas like that. Then we have also talked about the Northern American region which are higher latitude, which are closer to the polar regions like that, and some sort of experienced a very significant amount of these cold waves in 2019 like that. So this is some sort of example which tells that at the on one hand the heat waves events are very much likely occurring in different parts of the world. At the same time, we are also observing a very cold events or where the temperature drops very significantly, and that disrupt the overall socioeconomic condition in those regions like that. So both the extremes are happening at the same time because of the change in the weather pattern and enhanced by global warming, climate change like that, and therefore we are observing these types of extreme events which are occurring in different parts of the world. Then we have also discussed that what is exact cause of the cold spells, let's say in the higher latitude region. We discussed that okay, there is a stable polar vortex region which basically stabilize the cold air in that particular region near to the Arctic or those polar part of the region. Then because of disruption at this polar vortex where the wind velocity is very high, revolving at such a very high speed, it basically moves towards the lower latitude region or extratropical regions like that, and therefore it basically enhances the temperature minimum threshold, and temperature goes below to certain degrees, and therefore it creates some sort of cold wave event in those regions like that. Then at the same time, when you have more ice formation, it basically also propagate this effect because ice generally reflect back most of the radiation back to the sky because of the albedo effect, and therefore it further propagates this effect of cold spells or cold waves in those regions, and therefore that basically affects the overall cold temperature extremes conditions in those regions like that. Then in the lecture 2, we had slightly shifted our focus towards precipitation extremes. We talked about extreme precipitation events which are happening all across the world. This is also some sort of extreme climatic events, and which is we have already discussed that these types of events are classified based on certain thresholds, right? So these thresholds can be percentile wise or percentage wise, or let's say this threshold can be a magnitude wise as well. A certain degree, if the daily rainfall increased above that, it can be considered as a very severe storm event or very severe precipitation events like that. So extreme events are also increasing, and therefore we have also observed in the historical time record that several regions across the world has been suffered because of the extreme precipitation events. If you just take a few example, for example, there is a event occurred in Uttarakhand region that is called Kedarnath event, which is also fueled by extreme precipitation event. Or there are some other events, for example, we see that urban floodings are more common in different places of the world because of the more extreme precipitation events, and the water stagnant there for a very long period of time, and therefore creates some sort of floodings kind of situation, and then there are so many other indirect effect, health hazards like that. Then we have also talked about in lecture 2 in different global warming scenarios, the precipitation extremes are continuously rising, and therefore we are observing more intense extreme precipitation event in the changing climatic scenarios as well, which was not observed in the historical time records, but we are observing these types of events more frequently because of the change in the nature of your let's say atmospheric carrying capacity of moisture, and therefore you have more intense rainfall in a certain places all across the world. This also enhances sometime the written period of different types of extreme events calculations. That is called, in more advanced terminologies, that is called non-stationary conditions of the extreme events, where the written periods are also keep on increasing or changing because of the influence of certain different stressors or covariates like that. Then we have also talked about at different temperature, when the 1.5 degree will increase, 2 degree will increase, 4 degree will increase. There are more of these regions, for example, equator region and near equatorial region and their polar regions like that will also likely to be experience increased amount of precipitation in near futures like that. Then we also talked about when the rainfall is increasing, that will have a certain linked hydrological hazards or extreme events. For example, it could be floods. So when you have more rainfall events, at the same time more snow melt and more ground is saturated, or let us say you change the land use land cover condition, more you have changed the infiltration properties of land use land cover because of the human activities and all, that sometimes basically propagates this flood events more severe in a certain region. For example, if the some sort of river section has been occupied or the floodplain region has been occupied for some sort of industrial development or urbanization or settlement of some areas, those areas are already in the floodplains, are basically can be considered as where the high flow will come, and that is basically likely to be inundate those regions. That is basically called change in the land use practices, and therefore can affect the the flood vulnerabilities of those regions like that. For example, if you have the intense rainfall event and it surpasses the, let us say, infiltration rates of a certain region, it can also generate a very quick runoff condition, and therefore it can call as a intensity driven runoff. Or let us say if you have the more snow melt which was in the summer period, and therefore it saturated the ground cover already, and therefore you have more prolonged period of long precipitation events, which basically generates longer duration runoff events in a certain regions like that. So this is also happening. At the same time, there are some natural factors, there are some human made factors which are combining together to amplify the effects of floods which are linked to the extreme precipitation hazards like that. Then we have also discussed about another type of extremes when we do not have rainfall at all for a very a prolonged period of time. That can create the drought condition when we have very severe severity of water surface water availability in a certain region. That can link to multiple different types of drought hazards. For example, it could be hydrological hazards drought conditions, it could be agricultural or ecological drought conditions, it could be environmental drought condition, or it could be socio-economical drought conditions, because changes in the water surface, changes in the groundwater availability, and then the crop productivity, and then other linked socio-economic activities are affected because of the changes of these water areas like that. So there are several stresses, for example, temperature rise, changes in the precipitation pattern, or increase in the radiation, increase in the wind velocity, or humidity is very low, like that. There are so many different factors naturally, and at the same time, so let us say if you change the land use land cover conditions, or some sort of human activities, if you start there, that can basically also affect the drought propagation or drought activity in a certain region like that. So this is we have also covered in lecture 2 part. Then in lecture 3 mostly we talked about what is exactly other type of extreme events conditions. For example, we had discussed about extreme weather phenomena, that is called tropical cyclone, storms, typhoon, or let us say so many other names we say across different parts of the world. So we talked about in the lecture 3 that these tropical cyclones are intense low pressure system that forms over warm tropical ocean. Almost this the temperature of warm ocean could be around 26 degree or 27 degree like that. it gets the moisture from the ocean surface, and it basically generated by the temperature rise in the sea surface area in those region, and this is basically how it basically generates, or this is a kind of a favorable conditions for tropical cyclones to be generated in a certain region like that. Then we have also talked about different types of nomenclature which we say in the literature or different parts of the world, hurricane, typhoon, like that. Then we have also talked about what is exact mechanism behind the tropical cyclone, how it forms. We talked about warm ocean that fuels the tropical cyclones driving their development, then rising water vapor which cools, condense into the clouds and release the heat in the atmosphere, and this release of the heat of the air causing it to the rise, draw in surface air, getting more stronger and stronger, and therefore you have more strength of the tropical cyclone in a certain region. Once this eye is formed where the area is more stable and there are surrounding regions, for example, so these regions basically moves around the oceanic bodies to basically land surface areas. When it moves to the land surface areas, it weakens because it loses the oceanic heat as well as the moisture transport from the ocean surface, and therefore it weakens overall the tropical storm activity. However, when it comes to the coastal region, this tropical cyclones creates most of the catastrophic conditions because of all these coastal regions are very close to the sea surface areas, and therefore it creates more hazardous conditions there. Then we also talked about in the lecture 3 that historically we have observed that tropical cyclones are keep on rising at different velocities, at different areas within 4-kilometer area or outside 400-kilometer areas like that. So all these tropical cyclone phenomena are keep on rising because of the change in the sea surface temperature, because of the global warming, and that basically makes more favorable conditions to form these the tropical cyclone conditions, and therefore we have seen that there are several regions where the the tropical cyclones are keep on rising. There are several regions where the exposure has been decreased. There are several regions where the movement is slightly slower and longer season like that. So there are so many different types of impact which we have already seen because of the global warming or human induced global warming across the world like that. So this is we have so far discussed in the past 3 lectures. We have covered multiple different types of extreme climatic and weather events, and which is basically can be classified under different types of categories: temperature thresholds, temperature categories, precipitation types of categories, or other weather extremes kind of categories like that. Moving forward, so in the today's lecture we will also I will describe what is the assignment we have to now we have to work on based on whatever we have so far studied in lecture all these 3 lecture in week 2. So the second assignment of this week 2, this is the first assignment of week 2 basically. So in this assignment we have basically have to work on different types of hydrological extreme events or across the different parts of India or district level or let us say state level as well. So in this assignment what you need to do is you have to look at this particular website which is called India Flood Atlas, which is the HTTPS, the website address is also written here. Here you can go that in that website and you can look at the flood data set, historical flood data set across different district of India. What you need to do is basically you can first you need to identify most vulnerable region because of the flooding event in past, let us say 1901 to 2020 120 years, and based on that vulnerability map you basically identify which of those region in India are highly vulnerable in terms of flooding, how many times we have observed the flooding events in those different districts like that. Then once you do that, you can basically look at, you identify 3, 4, 5 districts, and you try to look at the the percentage flooded area data using this particular website, to look at how many times what is the percentage of data has been flooded during different types of flood events, or is there any trend you can observe, or is there any rising trend you are seeing, or is there more or less stable pattern, it is sometimes increasing, sometimes decreasing, like that, or is it any kind of trend you can observe in the recent, let's say 120 years whole time span, like that. So this is the first part of this assignment, and in the second part of the assignment you also look at drought extremes, which is called other hydrological extreme, which is when we do not have sufficient amount of rainfall, therefore hydrological drought, agricultural drought and all, but here we are saying this is some sort of hydrological drought conditions. So using this data set, you explore the data and you try to identify what is the overall drought severity areas across the India, and how we can interpret them. And then you can also look at, similarly to the flood time series data analysis, you can also look at drought time series analysis, and you can tell, okay, these are the vulnerable areas, how many times we have reported the drought events in those areas, like that. So this is what you can do, you can practice. This will give you a more better insight about, if I am saying that floods are increasing or floods are rising, whether the observed data set is also suggesting the same story or something else. Maybe there are some regions where the floods are significantly rising, or there are some regions where we observe that it is rising but gradually rising, or there are some regions where there is no increment at all. So these kind of the analysis we will do based on the observed data set record, and that can tell us about what is the overall vulnerability of these regions based on two types of different extreme conditions. One is your flood, one is your drought, and then you can club it together, and then you identify, okay, these areas which are also affected by flood vulnerability, plus these areas are also affected by because of the drought vulnerabilities, like that. So this is you can do, you can practice this assignment, and we can discuss further about what is the solution of this week 2. So far in this lecture we had discussed about what we have so far covered in the this week 2, lecture 1, 2 and 3 of week 2, and then we have also discussed about what is the assignment based on these 3 lectures, so that you can identify the regions where we have seen a more intense rise of, let's say, extreme climatic impact events or hydrological events across different parts of the country region in the India. That will give us a more better insight about hydrological extremes, like that. Thank you so much for your attention.